Assalamualaikum and hi everyone. In these slides, we will explain to you about manufacturing applications by using linear programming. Our group members are Badruddin bin Zakaria, Siti Nur Hijrah binti Basri, and me, Muhammad Syed Hafiz bin Abdul Rashid.
Okay, let's start with introduction. Greenberg Motors manufactures two different electric motors for sale under contracts to Drexel Corp. Drexel places order 3 times a year for 4 months at a time. Greenberg want to develop its production plan for the next 4 months. As we can see for the table, we have two models, which is GM3A and GM3B, and also we have 4 months, which is start with January, February, March and April. For the model GM3A, on January we have 800, February 700, March 1000 and April 1100. For model GM3B, we have 1000 for January, 1200 for February and 1400 for March and April. Okay, production planning at Greenberg must consider 4 factors. First, desirability of producing the same number of motors each month to simplify planning and scheduling. Necessity to keep inventory carrying costs down. Third, warehouse limitation, and the last is no layoff policy. We can use the same approach to create the portion of the objective function dealing with inventory carrying cost. IAI equal to unit of GM3A left in inventory at the end of month, and IBI equal to unit of GM3B left in inventory at the end of month. The carrying cost for GM3A motors is 0.36 per unit per month, and the GM3B cost 0.26 per unit per month. Monthly ending inventory level are used for the average inventory level. We can see the cost of carrying inventory.
Now, we combine both model GM3A and GM3B motors for the objective functions to minimize the total cost. As we can see on the slides, we got the objective functions by using QM for Windows to minimize the total cost. For the demand constraints, Greenberg stated that they starting a new 4 months production cycle with a change in design specification that left no old motors in stock on 1st January. So, the January demand becomes IA1 equal to 0 plus A1 minus 800, IB1 equal to 0 plus B1 minus 1000. Then, we return the January constraints. It becomes A1 minus IA1 equal to 800 and B1 minus IB1 equal to 1000. For February, March and April, the demand keep increasing for both model, which is model GM3A. The demands in February is 700, 1000 in March and 1100 in April. For model GM3B, is increasing from 1200 in February and 1400 in March and April. The last one, the constraint for April ending inventory is IA4 equal to 550 and IB4 equal to 300. Okay, next. Here is the constraints for labor hour and storage. We can see that the minimum and maximum hours for each month. As we know, Greenberg has a base employment level of 2,240 labor hours per month. By adding some temporary workers, available labor hours can be increased to 2,560 hours per month. So, it will maximize the production level and minimize the cost.
After we know the objective functions and also the constraints, we key in the value into QM windows to analyze the results. So from the results, we know that the optimal solutions for each variables. Then based on the result we got, the for variable IA1 and IA2, IA2 and IB1, we know that there is no optimal solution, which is 0. And then from the result also, we know that the minimum cost for this factory is 169,294.9. Okay. Then the result also shows the range of optimality constraints. Means each variable has their limits to get the minimum cost. Okay, let's for example, for A1, it is between negative infinity until 20.02. Okay, let's say the value A1 is 21. Means we got the new cost, which is a little bit increase from the minimum cost. We want to the minimum cost, so that's why we have the range of optimality constraints to get the minimum cost for each variable. Okay, that's all.
As a conclusions, we can see that the labor scheduling is very important for manufacturing industry. This is because it will make the productions become more efficient and flexible in the future. So that's all from us. Thank you.